floating wind energy will also be the topic of our next panel. But from a different angle, floating wind energy is supposed to take over from bottom-fixed offshore wind energy from a certain water depth on. But that frontier is actually being pushed back. And to talk about that, I'd like to ask Bjørnar, EIDE, and Stéphane JANISZEWSKI to join me on stage. Hello. Good morning. Hello. Hi, how are you? Have a seat if you want to. Thank you for being here today. Bjørnar EIDE, you are CFO at UK-based Entrion Wind, a subsidiary of the Entrion Group, founded 4 years ago. And your company is developing a technology that pushes monopiles into deeper waters. How does it work?
Our technology extends the operating depth of the conventional monopile from 55 to 120 meters.
Can you hold the microphone really close? Close.
Yeah. It consists of a specially designed monopile. It has mooring lines, anchors. This know-how and competence comes from the oil and gas sector, and we do have a unique developed top mooring assembly, a connector that connects the mooring lines to the monopile. In essence, the whole structure then conserves the structural integrity of the conventional monopile to deeper waters. So it's a combination of mooring lines, anchors, and a unique hydraulic solution that connects the mooring lines to a monopile.
And where's the technology at right now?
The technology is at TRL 6, so we've done most of the component testing of all the components. The certificates getting issued these days, and we will now embark on the next phase, which is to demonstrate the technology in waters, and are looking for alternatives for a demonstration project.
How far away from a first project that could be installed are we?
We believe that it's commercially possible to compete for projects already in 2027, 2028. Within the boundaries of the supply chain, our technology consists of components and a T&I part that is feasible technically within the boundaries of the existing supply chain.
Right, and so which countries, which kind of projects are you looking at?
We are looking at a lot of projects and are especially engaged in doing a lot of feasibility studies, technical and commercial feasibility studies in Europe. Our technology has a reach in Europe and in Asia. We released a report yesterday together with TGS, 4C Offshore, where we identified about 44 gigawatts of opportunities pipeline from 2030 to 2040. That gives us a compounded annual growth rate of about 28% for the whole period, with a higher growth rate from 2030 to 2035.
Right, and in advance of this conference, we were talking obviously about this topic. You were saying we're not really a competitor to floating, right?
Well, this is the key. We believe that our technology basically comes into play already in 2027 to 2028. So within the existing constraints of the supply chain, a lot of the floating technologies and economics around the floating technologies are probably going to come at a later stage, as well as for deeper waters. So we are focused on our water depths from 60 meters to 120 meters.
And that's not really a problem.
It's not really a problem. It's complementary to floating technologies.
And do you feel that market players understand that they're looking at both technologies at the same time?
Yes, we have had incidents and requests for studies where the build-up of larger fields are planned to both involve floating technologies and our technology.
And when you look ahead, what's your estimate of what market share a technology like yours or similar technologies could take up in the future?
That is a very interesting question. We've done external market sizing studies to answer that question. The recent study we did now with the TGS estimates that we have a minimum market share at least 20%. In this time frame where we're going to be commercial available, we believe that it could go much higher than 20%, but a conservative estimate of the 44 gigawatts about from 2030 to 2040 would be around 20%.
Another technology that could blur the boundaries between floating and bottom-fixed offshore wind is yours, Stéphane JANISZEWSKI. Oh, is it working? Can you try again?
Yes, that's right.
Okay. You are a sales coordinator at Schwanau-based tunneling specialist Herrenknecht. That's my home country. So how do your devices work?
So Herrenknecht has a history in the tunneling. So we come originally from the tunneling industry. And they basically, for the last 40 years, they've been building tunnel machines. And I think in the last 10 to 15 years, they've been wondering, okay, if we turn it 90 degrees, we put it in the water, then we end up with a solution for the offshore market. So that's where the technology comes from. It's very similar to the tunneling. We've got a full phase excavation, enabling us to go to achieve quite high speed of excavation. It's a drilling process where a lot is tailored to the geology of the different sites. So we've developed an installation process with our partner DEME, and together we've been able to achieve a quite efficient process. On one side there's a machine, and on the other side there's a subsea template and a liner.
And you told me that this process can actually also be used for floating offshore wind farms.
Yes, for the floating, we're looking at a scaled-down version. So today we've developed a machine that's about 8 meters. That was the one used in Saint-Nazaire and Noirmoutier. And the floating is obviously into deeper waters. And on the machine side, we're confident that our machine can be used down to 700 meters. So
700?
Yeah.
That's quite deep. Can you tell us a bit more about the French projects you just mentioned? What happened there? What did you do? How did it go?
So, yeah, absolutely. So sorry, the last slide for the scaled-down version. And here we see the Noirmoutier and Saint-Nazaire projects, where a total of 134 monopiles have been drilled. So with our partner DEME, and what you see here on the picture, you've got the machine itself, but also the innovation jackup vessel and the subsea template called Modiga. The average speed was quite high, so we're very happy with that performance of 2.5 meters per hour, which is set as a good record for future projects.
And are you looking at other French projects as well? Are you in touch with the market participants, I suppose?
Yes, absolutely. I would say for the future, we have this scaled-down concept for the floating and jacket application. So that's one direction. The other direction is I'm just gonna sorry. It's the number. So here on the number 1 is the floating one. Number 3 is also a relief drill. So that's targeting, I would say, the monopile that's installed through a drive process, and where sometimes you can encounter a harder layer or a boulder, and we are developing here a backup solution to remedy from that harder layer.
And apart from France, what other markets are you looking at right now?
I would say it's really, we are worldwide exposed. We have subsidiary worldwide from the tunneling industry. So we are, I would say, looking everywhere where drill is required. So yeah, geology dependent, I would say. Yeah.
If we look at the two countries, your two countries, do you think you'd be complementary or maybe competitors?
No, I think what we see in a lot of feasibility studies is that the soil characteristics are very important in design and dimensioning of foundations. So I think we just talked about that, what an impact it has economically. So cooperating and involving the technical know-how early on for projects are very important.
Yeah, absolutely. And we see I understand the Entrion solution as I would say, a lighter monopile that will enable the monopile architecture to go into deeper water. And from our position, it's clear that if the soil requires drill, then we'll be happy to adapt the concept, the machine concept, to fit into the architecture from Entrion.
And do both of you feel that there's a lot of appetite for such solutions in the market right now?
I think the complexity of bidding for larger projects puts emphasis on the pre-planning processes and definitely the feasibility studies, technically feasibility studies. And what we see is that the soil input data for global motion analysis and understanding if drilling is required or there are special considerations are going to be very important going forward with the type of capital outlay for developers.
Right. Would you agree with that?
Yeah, and from Herrenknecht side, I would say from the machine supplier side, we see a lot more interest picking up in drill for the simple reason that the feedback we get from developers that the easy sites are now gone, and the sites that are developed have some sort of challenges, geological challenges involving quite often drilling.
So that would be one method to widen out the area with bottom-fixed offshore wind while we're waiting also for the floating offshore wind projects, right?
Yeah, correct.
Yeah. Thank you very much. Fascinating. Thank you both for joining me here today. Stéphane, JANISZEWSKI, and Bjørnar EIDE. Thank you for coming here.
Thank you.
Thank you. Thank you, everybody, for listening.
Yeah.